All right, YouTube, let's keep going on the chess engine. And in this video, I want to clean up our tests. And to do that, let's just start by opening up Emacs, and then we can run the test suite. And so, first of all, there's a warning. Let's remove that. Oops. Okay. Then there's a lot of passing tests, which is good. But what I really wanted to see was that there are some tests that don't really assert on anything. They just print some information. These are the tests inside the night attack thing. I think let's run just those tests. Okay, so here they are. We can initialize the find, that's okay, and then we just print the bitboards. But let's instead make some expectations. So there's one for 0. That should be 0 should be the bottom left. So for that one, we expect to have ones only in position 8, 9, 10, and 17. So we do like this, and then we can assert that they are equal. Like that. Move that. And sure, let's do 40, why not? So where is 40? So 0, 8, 16, 24, 32, 40. And then we expect one in 32, 24, 25, 32, 33, 34, and 40, 48, 49, 50, and 48, 56, 57. Let's run that. It still passes, which is good. And let's just add one more. Let's add, actually for position 18. So for 18 we would expect 1 and 3 and 12, I guess, and 8, right? And then we want 12 plus 16, and we want 8 plus 16. And we want 28 plus 7 and 33. I hope I did that right. Okay, it didn't complain. So let's say that's the test for now. And that works. Great, and then we should not call this test print night attacks, but let's call it check. Okay. And just to double check. We still have something that's printing. This seems to be the array attacks. Yeah. Okay, so we only have one test here right now. The rest is commented out. Let's fix those up. Okay. So here we're just setting up occupancy. Let's make that a separate function. Like that. And it should return a bit port. Oops. Great. Now, and then instead of printing these guys, we want to assert on it. So the first one is the occupancy. Oops. And the second one is printing the southwest ray. Okay. So we could do something like this. Expected southwest at 6, 7, 0, and then we do in 1 to 8. We say not plus equals, but this one. Then I want to set the bit that is equal to rho minus I colon minus I times 8. But only if this is greater than 0 and this is greater than 0. Let's see if it accepts that. Yeah, so I wonder why that failed. Let me first of all do this. And do that. So it overflows right away. It claims probably I'm doing something silly here. Does it know that this is a bit port? Great. Tempted to subtract. Okay, so it's because we cannot subtract here, so we have to say if I is ever greater than a column or row. Oh, they like this. Then we are allowed to do this thing. Now it runs. And then we can say that we expect the southwest array at this index to be equal to this constant. And that failed. Let's try this. Okay, so for some reason it's including the first position here. I see why, because we need -1. Fantastic. Now we can remove that. And we could do the same here. But let's check west at 6, 7, and then I want to only decrement the column. This one stays the same. Then we can assert that array's west index is that one. Oops. That didn't work. And I forgot to say no, that shouldn't matter. And honestly, this function should just be called chessarray because we won't do blocking right now. What is wrong here? So I am quite tired today. Okay, obviously it was because we had the row greater than I, and then they truncated the loop. So now with this it works. And let's do one more. Now we will do northeast. So now column plus I should be less than or equal to 8, and the row plus I should be less than or equal to 8. Plus I minus 1. Great. We'll call this one northeast. And it passes. So perhaps in isolation this is a little bit weird, because we're kind of copying the, well, not quite. I mean, this is kind of is a little bit involved, and it's calling like a utility function, and there's a lot of things that could go wrong. So I think it makes a little bit of sense to have this test. Let's remove that. And then also this print statement, let's format. And I want to make another one, and then we should remove this one. And here I want to say that we want a blocked attack. So let me look back up here. We have this function blocked ray attack, which I think is not under test. Let's pick some other position like this. And then we want to say blocked attack is blocked ray attack. Let's do northwest. Actually, let's do something. Let's just check. That the northwest ray at this index with the occupancy, and then let's mark the index, and that makes some kind of sense. And we redefine it. We are missing some delimiter. Okay, so there will be like 1 bit set on this thing. Okay, so yeah, let's go back to this. Blocked attack is this ray with the ray family. Is it a forward ray? Yes. And then the occupancy. And then we want to say that there's only 1 bit set. What's the best way to do that? Well, we can just say that this blocked attack is equal to index plus 7. I need a reference only. That didn't work. So let's print it. Plug the text. There's 2 because if we print the occupancy, is that a bug? Okay, it's because it's assuming it can take this thing, which is kind of interesting because this blocked rear tag doesn't have support for the 2 types of occupancies. So for example, if this marked piece over here, if that were of the same color of this as this one, then we shouldn't be able to move there. But if it's the opposite color, then we should be able to. So we need to update this function like that. And let's say the first one is the enemy occupancy. And then we want to do something else with our own occupancy. And I think we can just not return the exclusive OR, but we can AND it with not our own occupancy. That should be correct. And then we can, this function should really, occupancy 1, it should really return something that we call the enemy occupancy. Let's do this. And then enemy occupancy. Enemy. And then we will return a tuple. Like that. Okay. And now we should have that this is equal to that. And also, if we switch what is considered our own piece and the enemy pieces, then we should be able to do that, and then it should only be the first one. And I didn't like that. It failed. It's an overflow. Attempted to subtract with overflow. In utils. Line 8. So it's getting a 0 bit. Maybe we should have an assert here that bit is not 0. And then if I go back, that we should hit that assert, right? And where are we actually using that? Huh. Okay, so this function actually doesn't work correctly if this overlap is 0. So we should say if overlap is 0, then I think we can just return the ray, because no, then we should return the ray and not own occupancy. Let's run that. Still it failed, and it failed at line 195. So we do what we always do. Huh. So again, we need to still do this scan where we like look for the first hit. So let's say enemy overlap, own overlap. And what do we want to do? Okay, I think I want to do something like this. And then we have to implement this function. Returning a bitboard. So we know how to scan the bits. And then an occupancy. And then it should return an option of an index. Not that, but like that. Okay. And now we have to do some kind of matching. Let's try. Enemy hit. So in the first case there are no hits at all, and then we just return the array. Now the thing we had implemented correctly is if there's an enemy hit, then we basically basically do this. IDX, why not? And we don't need the own occupancy because there is there's no hit with that, so we can remove that. Now, oops. Okay. Now, if there's only a hit with one of my own pieces, then I have to say something like, not the ray after. Here's what I can do. I can say we get the ray after that point, but then I actually want to XOR it with after plus something at that index. Now finally, if I both hit myself, my own piece, let's call it own IDX, and the enemy, then we have to do something complicated. And what do we have to do? I guess we can do this. And then we can return the ray where we have, first of all, our own after, plus that square, plus the enemy after, like that. What's happening? Okay, that should... I see why. Now, can this thing be simplified? We could have some kind of function that says try get from array family, and if it has like a none or whatever index, then it just returns 0. Then I think we could just but then we have to support this case as well. I don't know, maybe this is a little bit clearer than what I can think of right now, so let's keep it. Okay, then we have to implement first hit, and it's probably more or less equal to, well, I guess it's just if forward ray, then we do bit scan of ray sected with occupancy. Otherwise we do bit scan backwards. We run the test. Bit scan backwards. Right, so we have to write own IDX. Unnecessary parentheses, whatever. Guess we will say the same down here. Right, so okay, so now we have to have this handling. So let intersection and occupancy, if intersection equals 0, then we can return just array. Otherwise we'll do this. So I return here. And okay, we decided that it's an option and not some. Because it's the first hit function. Okay, so now the test is running correctly. Let's make a little bit more complicated occupancy. So now I want one where there's one of my own pieces in front of the enemy pieces. So I want to put some on squares 0, 8, 16, 24, 32, let's say 32 to 40, and we can say like, then we continue, otherwise we add, let's not do that, and let's keep that. So let's add a similar test to this, where it's several layers of pieces. Print, please. It's a bit weird that the test passed. Guess I'm just got lucky. Let's add another row. Okay. Let's do something. I mean, this is an illegal occupancy, by the way, so let's not do that. Still illegal. So let's just say or I equals 42, remove that one. 41. No, it has to be a multiple of 3. So why not 42? Why doesn't that do anything? Okay, but at least now we don't hit the 2 squares that are supposed to be occupied by this thing. So actually we can just add an assert here that there's no overlap between occupancies. Just to be sure. Good. And now for my final trick, let's just make completely sure we know where this is, and also that it doesn't overlap. I think we got lucky. Okay. Now the test is still passing, weirdly enough. That really should happen, I think. So no. So it's supposed to sit here, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then it should be blocked right away, but it's not. So let's try to see what's happening. Actually, let's use the debug thing. Enemy overlap. Still okay. So that's how it works. Okay, so that's great. I don't know why I printed that. Let's print this. And now that we have that, let's rerun our test. So it finds some hits. And down here, let's make a debug variable and have a look at that. Let's just run all the tests, whatever. Didn't like that. Unnecessary parentheses, whatever. dv equals something crazy. Okay, I have to run only that test. Right, because it's supposed to be or here, I think. Right, so because I don't want to hit my own and I don't want to hit what's after the first enemy. Both of those, so it should be or now the test failed, which is what we expected. So what should really be here? The blocked attack should actually be 0, which is correct. And if I swap the occupancy, then I just hit the first piece, which before was my own, so that's also good. And I think we don't need all these tests anymore. So I think that was good. We cleared out some bugs. We should really try with a backward ray as well. And then finally I should make another occupancy. It's gonna be the same as this. No, it's gonna be almost the same, but everything will be shifted down by 2 rows. 5. Let's see, 25, 26. Because then we can say it's because there's a failure here, there's some kind of overlap. That I somehow made. Okay, you know what? Let's do this. Okay, now we have some occupancy. Let's split it out so we can see what's going on a little bit better. So this is our own, this is the enemy. So let's maybe put a piece here as going southwards. So what is that? That is 1, 2, 3, okay, 7, 2. To look at the south ray. Great, so if I'm here and these are the enemies, then I should hit that one. And that is column 2. plus row 4. And it fails here. Because the blocked attack has several things inside it. It also has same column, but row 5. And finally, same column, but row 6. Okay, now it failed down here, which we expect. And we should have that it has the same as this, same structure as this, but without that one. Perfect. I think that'll do it for now, so see you next time.